G'day, KC here, and how you doing? In today's video, I'm just going to talk to you a bit about this channel, a new channel that I'm starting, and welcome. Thanks for taking the time to watch, and really just to go through a bit of the inspiration and what the channel's about. So when I was younger, my parents got me one of these for my birthday, and it's a clock, but it's a rolling ball machine. So this really got me interested in rolling ball machines and just mechanical, how things work. As you can see, then moved on to a few other rolling ball machines, but then I actually got a magazine, and every month or week, sorry, you'd buy the magazine and you'd get a part. And so this is what came out, and this is fantastic. You can actually see all the gears are, sorry, it's a bit dirty, could have done with the clean, are brass. The base is brass, and this really got me interested in brass gears and movements and what can be done. And I suppose also the reason I'm attracted to these sort of things is that they're a bit steampunky, which I also quite like. The whole idea of gears and cogs and what the world would be like if steam was our primary source of power. More recently we got this clock, and this really got me thinking because although the outer edge is aluminium, the gears and everything are all plastic. And I thought actually from a distance, this clock, I believe, still is fairly attractive, and yet it's made out of plastic. So I thought, well, if that's made out of plastic, why can't I 3D print something similar? So that really got me onto the idea for this channel and what I'd like to do. The first step was to find a clock that I wanted to try and make. So I did a bit of looking on the internet, and I found this clock. It looks like they've made it out of wood, but I thought, if they can make that out of wood, I'm sure I could make that out of plastic with a 3D printer. And so I thought, well, let me give it a go. The problem I had was that the clock doesn't show you all the gears. So you can see the gears in the middle, and you can see the gears, the planetary gears for each of the dials. But you can't see how it gets from the one to the other. Fortunately, there was another photo which shows a bit more of a cutaway look as to how it works, or a bit of a model. So that's how I started, by taking this model, and really what I did is started counting the gears, each one how many teeth, and to try and work out how many gears, where they need to go, how they need to set up, and everything else. And the idea was then to draw it up in Fusion 360 and do the design there, and then print the clock. So let me show you how I went about that. After playing with the gears, I couldn't get the numbers to add up with the number of teeth to understand how it would keep the time. So what I did is develop this spreadsheet. What I've done is I've made a column for the gear train, just so that you know which bunch of gears you're working with. I've also put whether it's the top, the middle, etc. And then the teeth, how many teeth are in that gear. And then to try and work out the speeds, I've put the revolutions per minute and teeth per minute. I mean, that's really just 96 divided by 16 gives you 6. It's as easy as that. So that's really just all I've done there. So if I have a pinion gear, I wanted that to run at about 12 revs per minute, because I'm going to be using a stepper motor. So I can achieve the 12 revs per minute on the stepper motor to power it. And then what I've sort of linked is you know, the 8 tooth is driving a 16th tooth, which is a compound gear, so it's got an 8 on it, but at the same time it's driving all these planet, the sun and the planet gears. But that middle gear then will drive this middle gear, and then you can see the bottom gear is smaller, so it's driving a 16. So an 8 tooth is driving a 16 tooth, so it's getting slower. And that 16 and 8 are joined, so then that 8 will be driving that 16, which is attached to that 8, so that 8 will be driving that 40, etc., etc. So the A is really the seconds. So you can see there that sun is turning at 60 revs per minute, or 6 revs per minute. 60 teeth per minute gives you seconds, so that'll be the second hand. If you work down, you can see all the different gears. So the green drives the yellow drives the yellow, the green drives the green, the dark green drives the dark green, etc., etc. And then I've come down to this sun is it's 1 teeth per minute, so that gives you the hour hand. So it basically turns every hour, and that's why that'll be the minute hand. You then come down and same idea, so that 8 will be driving that 24, again that the purple to purple, the red to red, etc. And then you come down and you're driving the last planetary system, and you'll see that sun gear is turning, it does 1 rev a day, so that means that that's the hour hand. I don't know if any of you have spotted the problem there, but let me tell you that a clock doesn't go around once a day, because that's 24 hours. It actually goes around twice a day, so it should have been 12 hours. So this one should actually be doing 2 revs a day. So that was a mistake I made, which you'll see throughout the build. So if you've watched to the end, thank you so much for watching. I know this video has been a bit dry, but the future ones will have the actual building of the clock. So as I say, thanks again for watching. God bless, and catch you on the next one. Please be sure to like and subscribe.